Okay, so today we're going to be factoring more complicated quadratics. This time they are going to have a leading coefficient in front of them. In the last section, we factored quadratic trinomials without a leading coefficient. Okay, so there was nothing in front here, which meant it was just a 1. All we had to do for that was consider the numbers that multiplied together to make negative 40. That would add up to that middle term, positive 6. So in this case, it would just be x plus 10 and x minus 4. That was it. Okay. In today's section, we're going to learn how to factor quadratic trinomials with a number in front. This is more difficult, but the more you practice it, the more you will get the hang of it. All right. Our first example today is when that leading coefficient, a, is a prime number, meaning it only has two factors, one in itself. So what we have to do now is we have to consider the factors of a as well as c. So what do I mean by that? Okay, well, if we have 5x squared plus 11x plus 2. All right. We know that from the FOIL method, anytime you have a binomial times another binomial, all right, let's say x a and x plus b, right? Your first times its first gets you that x squared. That's your f. Then you have your outside and your inside, and those make up the O and the I step. And then you have your last term, which is, in this case would just be AB. Okay, when we have a leading coefficient in front of that first term there, we have to consider, when we're factoring, this times this as a step. So we have to consider the factors of 5 that would make 5x squared. Well, in this case, that's really easy to do because a is prime here. All we would have are 5 and 1. Okay, because we know the first times the first gives us the 5x squared. That's the only thing that can make that work. We also know from our c step, or from our last step, this value of c only has two factors, 1 and 2. So once we set up from the leading coefficient, these two terms here, then we just kind of fill in the blanks here. Okay? The only options we have are a 1 and a 2 because the last times the last, right? That's where we get the AB, the last times the last is the constant. So the only numbers we can put here and here are either the 1 or the 2. So then what we're going to consider, we're going to do 5 times this one and the 1x times this one. So where can we put these two numbers in here and here so that they would eventually add up to 11? Okay, well, for us to do that, you might have to guess and check for a little while. Okay, if we just try the 1 and the 2 here, okay, well, you have 5x times 2, that makes 10x, and 1x times 1, which is 1x, which, hey, look at that. On our very first try, 10x plus 1x is 11x. This is indeed the correct answer. So 5x plus 1 and x plus 2. So when you have these leading coefficients, you are going to have kind of a little bit more complicated way to factor here. Okay? If you have 3x squared plus 16x plus 5, again, the leading coefficient is a prime number. So the only numbers that multiply together to make 3x squared would be 3x and x. Okay, so again, that's where we start. It also helps that the last number is also prime. So 5 and 1, okay, those are the two factors. We got a 1 and a 5 there. And again, we're going to be multiplying those terms together, the 3x times this one, and the 1x times this one. Okay, so let's just try this. Okay, if we put the 5 here and the 1 there, you have 3x times 1, which is 3x, and then you have 5 times the x, which is just 5x. Well, when you add those together, that makes 8x, not 16x. Okay, so that doesn't work. Okay, so that one's wrong. So we start over. 3x and x. Okay, well, we tried 5 here and 1 here. The only other option for us to try in this case would be the 1 here and the 5 here. So now when we multiply it out, 3x times 5 is 15x, 1x times 1, or 1 times x is 1x, so you get 15x plus 1x, which is 16x, and that's what we were looking for. So this would be the factored form for that one. Okay, so again, you might have to guess and check a little bit in order to do this. All right, so here are two more, both with the leading coefficient as a prime number. The last term now is negative. All right, so that's going to make this, again, even more difficult, which just means you get to play around with the negatives a little bit. But the good news for us is that we start with the 3. Okay, so again, that can only be 3x and just x. If we list the factors of 15, well, we could have 1 and 15, or we can have 3 and 5. And now we have to introduce the negatives in there as well, because the last term is negative. One of these, as I talked about last time, one of these numbers has to be a negative. Okay, so we're trying to get a positive 4 here. Okay, so we might maybe try something where we're getting to a positive number and then subtracting it down to a 4, or maybe we start with the negative number and add something to get up to the positive 4. Okay, but again, we can just test and check here. I'm gonna start with the 3 and the 5. Okay, let's start with the 3 here and the 5 here. Okay, if I multiply these out, okay, again, the 3x times the 5 gives me the 15x. 3 times x is 3x. I can't combine these to make a 4. So I can't have the 3 and the 5 there. Okay, but if I start over, 3x and x. Okay, let's try the 5 here and the 3 here. So now when I multiply them, I have 3x times 3, which is 9x, and 5 times 6, which is 5x. Can I combine these somehow, make a 4? Yes, I can, if the 5 is negative and the 9 is positive. So then I go back and I finish my signs. 5 has to be negative, and the 3 has to be positive. And that's how I'm going to end up doing this. Okay, so go ahead and try this last one on your own before I walk through it with you. Okay, with this 2, you have 2 and 1, so that's easy enough. And actually with this 7, you just have 1 and 7 as your two options there. Okay, now let's just think about this before we start guessing and checking. We need a negative 13. So I have to do 2 times something and 1 times something. Well, the only way I'm going to get to negative 13 is if I do the 2 and the 7 together. So that means the 7 actually is going to go over here, and the 1 is going to go here. So now when I have the FOIL, the O and the I step, okay, I have a 14x and a 1x. Well, for us to get negative 13, this 14 has to be negative, which means that this 7 was negative, and this 1 was positive, and that is the correct answer for this one. It gets even more complicated when you have a leading coefficient that is not prime. So far, we've only had to deal with just one option for those leading terms and those binomials. Well, if we look at 6 here, there's 2 ways we could do this. You could have a 6x and a 1x. I usually write the bigger one first. Or we could have a 3x and a 2x. Okay, so now we have more guessing and checking to do. Okay, but thank goodness for us in this example, the 5 is prime, so there's only 2 numbers that we are playing around with, 1 and 5. Okay, so let's just think about this. Okay, if I put the 1 here and the 5 here, I'd have 30 and 1. Okay, because 6 times 5 is 30, and 1 times 1 is 1. So that doesn't work. If I switch it around, 5 here, and 1 here. So then I have 6 times 1, which would be 6. 5 times 1, which would be 5. I can't get 13 out of that. I can only get 11. Okay, so this one's not going to work. So I move over to the 3 and the 2. Again, think about how we can do this. 3 times 5 is 15. 1 times 2 is 2. Can I combine those to make 13? Yeah, I can, but they're both supposed to be the same sign. I think I screwed up with this problem. No, I didn't, because they're the same sign. Okay, so again, if you do this right here, yeah, you end up with 15x and 2x. But because this was positive, those signs had to be the same, which would make 17, not 13. So this one doesn't work either. But if I go with the 3x and the 2x, okay, and I flip those around, I go to the 5 here and the 1 here. Now it actually works. 3 times 1 is 3. 5 times 2 is 10. And now when I add them together, I get that 13x. Okay, so again, they both have to be positive. So again, that one was tricky. It took us a while to walk ourselves through that one. Very last one today, 10x squared plus 31x minus 14. So we're starting with the 10. We know we either are going to have 10x and x, or we could have 5x and 2x. Okay, the last term is negative, so that tells us we're going to have one of each sign. So remember that right away. And we're playing around with a 1 and a 14, or a 2 and a 7. And our goal is to get 31. Okay, so I'll just kind of jump ahead here. If we do 5x times 7, you get 35, and 2x times 2 gives you the 4 that you need to get back down to 31. So you have the 35x and the 4x. In order to make 31x, and because this is negative, you can have a negative. This 4 needs to be negative. So that came from the 2, meaning that's positive over there. And that's how we do that.